हेलो एवरीवन, वेलकम टू माय चैनल फिजिक्स ट्रिक्स। आज हम फ्रिक्शन के प्रॉब्लम्स करते हैं एंड इन दिस एडवांस लेवल प्रॉब्लम्स ऑन फ्रिक्शन. So in this first question it is given, and as you can see over here, two identical blocks A and B are placed on a rough inclined plane of inclination 45 degree. The coefficient of friction of block A is 0.2 and that of block B is 0.3. The initial separation is given to root 2 meter. The two blocks are released from rest and find time after which the front face of the both blocks comes in the line and the distance moved by each block before returning the position. So this is the first question given. So in this question, what you have to do is firstly draw the free body diagrams of A and B. So I'm drawing the free body diagrams of A and B over here, and as you can see, this is FBD of block A I'm drawing here, and the FBD of block B I'm drawing here. Okay, so this is the 45 degree angle. We have a block A over here, and this is also the 45 degree angle, and block B over here, right? So these two are identical blocks, so we have mg downward. Likewise here also mg downward. We can take the components of mg along the inclined plane and perpendicular to the inclined plane like this. This is the components of mg along the incline and perpendicular to the incline. This is 45 degree we have, this is 45 degree we have. So we have mg is this component, mg by root 2, mg sine 45 is 1 by root 2, mg cos 45 1 by root 2. So it is mg by root 2. This is the normal reaction which we have, and the friction force is acting in this direction. So acceleration of A is in this direction, acceleration of B is in this direction. Here also the same thing, the frictional force which will act in this direction, and the normal reaction will be in the upward direction. So I'll consider this as A, I'll consider this as B, frictional force for B, frictional force for A. So I hope this is clear. These two FBDs are clear, right? And the initial separation between the A and B is root 2 given, that will calculate. Firstly, we'll calculate the accelerations of both these blocks, right? Now, how to find the acceleration of block A, right? So acceleration of block A is, this is the greater force which we have. As you can see, this one mg by root 2 is the greater force, fa is the smaller force. Likewise over here, mg by root 2, I didn't write over here, but you can write here mg divided by root 2. Here also same thing, mg divided by root 2. And as you can see over here, this mg by root 2 is greater than this fb. So you can say this mg by root 2 minus fb divided by m will be the acceleration of B, and likewise acceleration of A, mg by root 2 minus fa divided by m. Okay, so I'll just write over here, I'll just write acceleration of A, and that is equal to mg by root 2 minus the frictional force in A divided by mass, and the acceleration in B will be mg divided by root 2 minus fb divided by m. Now, what is the frictional force in A? Frictional force in A is 0.2 times the normal reaction. So I'll just write here. So acceleration of A is mg divided by root 2, right, minus the mu s is 0.2 times the mg divided by root 2, and this is in bracket we have divided by the mass. So this mass cancel, and the acceleration of A, if you want, you will have g divided by root 2. 1 minus 0.2 is 0.8, and it will be 8 divided by root 2. And similarly, if you just calculate the acceleration of B, you will get mg divided by root 2 minus mu s, that is 0.3 times mg by root 2 divided by m. And if you just calculate, you will get 7 divided by root 2. Okay, once we got acceleration of A, acceleration of B, we can have, actually we have the initial separation between these two blocks, root 2. That means the displacement of A with respect to B, or the displacement of B with respect to A, that is your choice, right? But we can write a displacement of A with respect to B is root 2 meter. Displacement of A with respect to B, we have to consider B at rest, so it will be root 2 meters, right? So initial velocity of A with respect to B is 0 meter per second, as it is starting from rest. Acceleration of A with respect to B is acceleration of A, that is 8 by root 2 minus the 7 by root 2 minus acceleration of B, and we'll get acceleration of A with respect to B as 1 divided by root 2. So displacement of A with respect to B is root 2 we have. So here I'm writing root 2, that is displacement of A with respect to B is equal to initial velocity ut plus half at squared. You can use over here S is equal to ut plus half at squared, that is the basic kinematical equation, and you will get half into A is 1 by root 2 into t squared we want. And if you just calculate this, as you can see, t squared is equal to 2 into root 2 into root 2 is 4, and from this t is equal to 2 seconds. That indicates in 2 seconds they will meet each other. Okay, front face will meet each other. And next, second question, the distance moved by each block for attaining the above motion. So the distance moved by each block, that is distance moved by A, will be half of acceleration of A into t squared, t just now we calculated, and the distance moved by B will be half of acceleration of B into t squared. And if you just calculate this, it will be half of AA is 8 divided by root 2 times the t squared, that is 4. This is 4, so 16 divided by root 2, and it will be 8 root 2 meters. And displacement by B will be, if you just want, it will be half of 7 by root 2 into, it will be like t squared, that is 4, and if you just calculate this, it will be 2, so it is 7 root 2 meters. So I hope this is clear now. So displacement of A and displacement of B just now we calculated, right? So this B will move 7 root 2 and A will move 8 root 2. So this is the solution. Now we have the second question, and that is the friction coefficient between the board and the floor shown in the figure is mu. So here the friction coefficient between the board small m of mass small m and the floor is mu, so that indicates this is mu given. Find the maximum force that can exert on the rope so that the board does not slip. So now here I can draw the FBD of capital M, that is man. So FBD of man will be, so this is the man, this is the rope tension T we have, again mg is acting in downward direction, and this m we have is capital M, as you can see. So this m we have is capital M g, and the normal reaction upward, right, and no other force is acting, so we can write directly n plus t is equal to capital Mg. Why? Because there is no motion, so sum of all the vertical forces must be equal to sum of all the downward forces, right? Okay, upward is equal to downward forces. Now I can draw the FBD of this board. So I'll just draw the FBD of board. It will be like this. This is the board which we have, and this is the floor which we have. On this is the tension T we have, and the frictional force in this direction. Then the normal reaction from the ground, normal reaction from the man, and small mg is there, right? These many forces are acting on this board, right? So if I just equate all the forces in the horizontal direction and in the vertical direction, then I'll get T is equal to, so sum of all forces in the horizontal forces direction is equal to 0, and sum of all the forces in the vertical direction is equal to 0. So I'll just write, so T is equal to F, or T minus f is equal to 0, because t I consider it positive. So t minus f is equal to 0. This indicates t is equal to f. And as you can see, ng is equal to n plus mg. That is normal force from the ground is n plus small mg, and n is what is called as capital Mg minus t, capital Mg minus t. So I can write the normal force from the ground, capital Mg minus t plus small mg, but we know that t is equal to f, so I can write as t is equal to f. This is equation 2 we have, this is equation 3 we have, and this is equation 1 we have, right? So this is equation 1 2 3, and from this 1 2 3, as t is equal to f, I can write excuse me, f is equal to mu s into ng, isn't it? Normal force from the ground. So tension, the maximum force that I want, so mu s into normal force from the ground is capital Mg minus t plus small mg, and if I just multiply and t from one side, so it will be t plus mu s t is equal to mu s capital M plus small m into g. And if I just rearrange this, t is equal to, I'll get mu s capital M plus small m into g divided by 1 plus mu s. And this is the final answer which we have. So I hope this is clear. Now the third question which we have is, an object is placed on the surface of a smooth inclined plane of inclination theta. If it takes time t to reach the bottom, if the same object is allowed to slide down the same rough inclined plane, it takes time nt to reach the bottom. Find coefficient of friction we want, right? Find coefficient of friction we want. So I'll just take the two inclined planes over here. So these are the two inclined planes, right? Only difference is one we have a smooth one, and other one we have a rough one, right? So in this smooth one, it takes a time t, and in this rough one, I'll take rough. This is the rough one, and this is the smooth one. Okay, so here the coefficient of friction is 0, and here the coefficient of friction is not equal to 0. So the length it has to travel is same. So the time required over here is nt given. So I can just directly write over here the time required. Now here the length it has to travel is L, and the acceleration in this direction, I'll just draw the FPT of this one. It will be in this direction. It will be mg in this direction. We have mg in this direction. Mg is this component, and mg is in this component. So this is theta, this is theta, this is theta inclination given. So and mg is this component we have is mg sine theta. Mg is this component we have is mg cos theta. If you want, why this theta? Because this is 90, this is 90 minus theta, so this is theta. Likewise over here, if you just consider, this is mg, this is mg's one component, mg sine theta, this is mg's other component, mg cos theta, this is theta we have, and the frictional force is acting, obviously, right? Okay, so it takes time t for this, it takes time t for this, and it takes time t for nt for this one. So we have to solve it now. So L is equal to the length it has to travel is L, so distance it has to travel is L, is equal to half into acceleration in the first case into t squared, and here the L in this second case is equal to half acceleration in the second case into n squared into t squared. Now L are equal, so I'll just equate initially only. So if I just equate, I'll get half a t squared is equal to half a dash n squared t squared. So this t squared half, this t squared half cancel, So I'll get A is equal to A dash into n squared. What is A now? What is A? As you can see over here, A will be g sine theta in this case, and I'll write g sine theta, which is equal to, what is A dash? As you can see over here, it will be mg sine theta minus mu mg cos theta, right? So that is g sine theta minus mu g cos theta into n squared, right? So now we want what is called as the coefficient of friction, that is mu we want. So I'll just take g sine theta common and cancel. It will become 1 is equal to 1 minus mu g cos theta by sine theta. I just took g common, so it will be cancel out into the n squared. So this n squared this side, it will be 1 by n squared is equal to 1 minus mu divided by tan theta, and from this mu divided by tan theta is equal to 1 minus 1 by n squared, and from this mu is equal to 1 minus 1 by n squared into tan theta, So as you can see over here, this is the answer. So 1 minus 1 by n squared into tan theta. Now if they gave theta is equal to 45 degree, you will directly say 1 minus 1 by n squared will be the coefficient of friction. Now one more thing over here, if you didn't understand how I got A dash, so A dash is equal to, I'll just calculate over here, A dash is equal to mg sin theta minus f, minus f divided by mass of the block m. So f over here, f I can write mu into the normal force, and that is mg cos theta. So if you just put it over here and calculate, you will get g sin theta minus mu g cos theta, right? So I hope this is clear now.